Hi friends, in this video we are going to discuss two problem about maxima and minima. So here example 1 given, discuss the maxima and minima of this function in two variable x and y. So in example 1 a is strictly greater than 0. This is my given condition. So here I want to write the given, here I want to write the answer of my question number 1. So here given f of x comma y which is equal to x cube plus y cube minus 3axy with a strictly greater than 0. This is my given information. Now I want to find the maxima and minima. I want to discuss the maxima and minima of this function. So here first working rule for maxima and minima. Here first working rule, here solve dou f by dou x equal to 0 and dou f by dou y equal to 0. Second, find r equal to dou to here. After this, here find solve dou f by dou x equal to 0, dou f by dou y equal to 0 and find the critical point. So here find the stationary point, here stationary point a comma b. So with the help of this. So now second thing, here find r equal to dou f by dou x square and s equal to f x y and t equal to this is f y y. Now at here, now we have to check at a comma b the value of r s t. So here at a comma b find r s and t. So here if r s t variable of x y z, so sorry x and y. So here at a comma b find the value of r s t. After that here check here r t minus s square is greater than 0 and if r is greater than 0 then function has maxima. So here function has minima. Here second, if rt minus s square is greater than 0 and r is less than 0, function has maxima. And third, here rt minus s square equal to 0, test fail here. And last condition, here if rt minus s square is less than 0, function neither has maxima and neither has minima, and that pair a comma b is my saddle point. So here saddle point. So this is the way to check whether the function has maxima and minima. Now here I want to solve this question. Here given f of x comma y equal to this. So here first step, here step 1 solve dou f by dou x equal to 0 and dou f by dou y equal to 0. So here I want to solve dou f by dou x which is equal to, so here 3x square and y0 minus this is 3a and y. So here partial derivative of this function with respect to x is minus 3a y which is equal to 0. Now so let's say this is my equation number 1. Now I want to solve dou f by dou y which is equal to, so here 3y square and minus 3ax which is equal to 0. Now this is my equation number 2. So from equation 1 can I write 3, so x square, so 3x square equal to 3ay. So 3 gets cancelled. This implies x square equal to ay. Now from 2, so here from 2 I want to write here 3y square equal to 3ax. This implies 3 gets cancelled. Therefore y square equal to ax. Now so here I want to here y square equal to ax. Therefore squaring y power 4 equal to, so here ax square. So here a square x square. Now y power 4 equal to, so here I am taking squaring on both sides. Y power 4 equal to a square x square. Now so here y power 4 equal to a square, the value of x square is a into y. So here y power 4, so which is equal to, can I write y power 3 equal to a cube. Now here y cube minus a cube which is equal to 0. Y cube minus a cube equal to 0. This implies y minus a here so wait. So here this implies y power 4 minus, so y power 4 equal to, so a, this is x square is the value of x square is a into y, so a square into, so here y power 4 minus, so y power 4 minus a cube y which is equal to 0. So here I will take y common, so here y cube minus a cube which is equal to 0, this implies y equal to 0, and so here y minus, so here y equal to 0, so here I will write this is y minus a y square plus a y plus a square which is equal to 0. Now so this is my root here, no, so you can find this in rough, no need to solve this whole equation. So here y into y minus a, so this is, and so here this implies that, so here either here y equal to 0, y minus a equal to 0, or this. So here but I think this root here, just observe one thing, y square plus ay plus a square equal to 0, and y equals minus b, so minus a plus minus under root b square means a square minus 4 into a into c divided by a square, 2 times a, this is 1, which is equal to minus a plus minus under root. So here I will take a square common, so a square 1 minus 4 divided by 2 times a, so here yes 2 times, so this is equal to minus a plus minus, so here square root get cancelled, this is a and this is under root minus 3 divided by 2 which is equal to, so this is less than 0, but here in the given a is strictly greater than 0, that's why just forget about this factor, just from these two factors, so you can take the value of y as here y equal to 0 or y equal to a. Here if y equal to 0, now tell me if y equal to 0, therefore x square equal to 0, this implies x equal to 0. Now when y equal to n, when here this is when y equal to 0, when y equal to a, this implies x square equal to a square, sorry, a into a which is equal to a square, therefore x equal to, so here simply plus minus a, so here which is equal to a, because a is strictly greater than positive. So here this is my a, here therefore my critical points are here, just observe one thing, critical points are, one critical point is 0 when y is 0, and another critical point when x is a, y is a. So when x is a and y is a, therefore the critical points are, so here you can solve this. So after that here if you want to write this explanation, so therefore critical points are, we can say stationary points are 0, 0 and a, Now I want to find nature of my function at this critical point. Now I want to find RST. Therefore now find r equal to dou 2f by dou x square. So here dou f by dou x is this, dou 2f by dou x square is 6x, and t equal to, so here sorry s equal to, first find s equal to dou 2f by dou x dou y which is equal to, so here dou x dou y, so which is equal to here minus 3 times, so here a, so this is 0. Now t equal to dou 2f by dou y square which is equal to, so here this is 6y. Now here, now at 0, 0, at 0, 0 find RST. So at 0, 0 r equal to, so here put x is 0, y is 0, so 0, s equal to minus 3 times a and t equal to 0. Therefore rt minus s square equal to, so here 0 into 0 minus of minus 3a, sorry 3a square equal to, so here this is 0 minus, so this is 9a square which is less than 0. So here a square is greater than 0, but a is greater than 0, a square is greater than 0, but this is 9 and this minus sign, so this whole quantity is less than 0. Therefore rt minus s square is less than 0, at that time your function neither has maxima nor has minima. Therefore at here 0 comma 0 function f of x comma y neither has maxima nor minima. So here therefore function is neither have maxima nor have minima. At that critical point or stationary point is called saddle point. Therefore 0 comma 0 is a saddle point of function. Now I want to check my nature of my function at a comma a. So here I don't have space. So now I want to check the nature of my function at a comma a. So now here I want to find now at a comma a. Now find the value of r, s and t. So here now at a comma a. So here find the value of r, s, t. Therefore r equal to, so here a comma a. So this is 6 times a. S equal to minus 3 times a and t equal to 6 times a. So just put the value of x as a, y as a. So therefore rt minus s square equal to here 6a minus, so here minus 3a whole square, which is equal to here 36a square minus, so this is 9a square. So here which is equal to, so here 36 minus 9. So here you can observe one thing. So here 36 yes. Yes, this is 27 a square, but here a is greater than 0. So a is greater than 0, a square is greater than 0. Therefore this quantity is strictly greater than 0. And here s equal to 6 times a. A is greater than 0, 6 times a is greater than 0. Therefore rt minus s square is greater than 0 and s is t or r. So here r is greater than 0. Therefore function has function has minima at, so here function has minima at this a comma a. Therefore your function has minima at stationary point a comma a. Therefore with minimum value f at here, minimum value at a comma a equal to, so here just put a cube plus a cube minus 3a into a, which is equal to 2 times a cube minus 3 times a cube, which is equal to minus a, so here minus a cube. So this is the minimum value of my function at a comma a. In this way you can solve this example. Now I want to solve my example number 2. So here this is the minima of my function at a comma b. This is the here function neither has maxima nor has minima at 0 comma 0. Now I want to solve example number 2. So here I want to discuss the maxima and minima of my function of this about 3x square minus y square plus x cube. Now here I want to solve my example number 2. So here I will start writing here. Now given information here, given x, so here I will write. So my given information is, so here f of x comma y equal to 3x square minus y square plus x cube. Now I want to find the discuss the maxima and minima. So here first step we have to solve dou f by dou x equal to 0 and dou f by dou y equal to 0. Therefore here dou f by dou x equal to, here dou f by dou x equal to, so here partial derivative of this function with respect to x, 6x plus 3x square equal to 0. Let's say this is my equation number 1. Now partial derivative of this function with respect to y, so keeping y x as a constant, dou f by dou y equal to, so here minus 2y which is equal to 0. This is my equation number 2. So here from 2 minus 2y equal to 0, this implies y equal to 0. So here this is my y equal to 0, and from 1, so here from 1 6x plus 3x square equal to 0. This implies take x common. So here take x common, 6 plus 3x equal to 0. Here x equal to 0, or here 6 plus 3x equal to 0. This implies 3x equal to minus 6, x equal to minus 2. Therefore x equal to 0 or x equal to minus 2 is the root of this equation. Therefore the combined roots here, therefore here at x equal to 0 here and y equal to 0 pair, one pair, and x equal to minus 2 and y equal to 0. So this is the two pair. So here one pair and this is the two pair. These are the stationary point of my function. So these are the stationary point, are the stationary point. Stationary points. Now I want to find RST. So here now find R equal to, so here find R equal to dou 2f by dou x square. So here this is my dou 2f by dou x, then dou 2f by dou x square is, so here this is equal to 6 plus, so here this is 6x, 6 times x, and I want to find t equal to, so here s equal to dou 2f by dou x and dou y. So here this is completely in terms of x, so here partial derivative with respect to y is 0, and t equal to dou 2f by dou y square, dou 2f by dou y square equal to simple minus 2. Now at here at 0 comma 0, now I want to find at 0 comma 0 RST. So at 0 comma 0, so here r equal to, so r equal to 6 plus 6 times 0 which is equal to 6, and s equal to 0 and t equal to minus 2. Therefore r t minus s square equal to, r is 6, t is minus 2, here 0 square which is equal to minus 12 minus 0 which is equal to minus 12 which is less than 0. Here rt minus s square is less than 0. At that time your function neither has maxima nor has minima. Therefore function f of x comma, here function f of x comma y neither has maxima nor minima at 0 comma 0. So at this point your function neither has minima nor has minima, therefore this critical point becomes stationary point. Therefore 0 comma 0 is a saddle point, of function f of x comma y. Now at minus 2 comma 0, now at minus 2 comma 0 r equal to, so here when x is minus 2, so here 6 plus of, here 6 plus 6 into minus 2 which is equal to 6 minus 12 which is equal to minus 6, and s equal to 0 and t equal to minus 2. Therefore rt minus s square equal to, so here this is minus 6 into minus 2 minus 0 square which is equal to 12 minus 0 which is equal to 12 is strictly greater than 0, and here r equal to, so minus 6 is less than 0. Here rt minus s square is greater than 0 and r is less than 0. At that time your function has maxima. Therefore function has maxima at here minus 2 comma 0 with maximum value. So with maximum value at minus 2 comma 0 which is equal to, so just put x equal to minus 2 and y equal to 0. Here 3 times minus 2 square minus 0 square plus minus 2 cube. So here 3 times, this is 9. So here 3 times 4, that is 3 into 4 minus, here 2 cube is minus 8, this is minus 8. So here 12 minus 8 which is equal to 4. This is the maximum value of my function at minus 2 comma 0. In this way you can solve any example. So here, so this is my function in two variable. So working rule, first solve dou f by dou x equal to 0 and dou f by dou y equal to 0. With the help of that you will get the stationary point. After that find RST, r equal to dou t f by dou x square, and s equal to dou 2 f by dou x dou y and t equal to dou 2 f by dou s square, and check the rst at 0 comma 0 at critical point. Here if rt minus s square is greater than 0 here and r is greater than 0 here, about this example, sorry, rt minus s square is greater than 0 and r is less than 0, therefore your function has maxima at minus 2 comma 0 with maximum value at minus 2 comma 0 is 4. So here in this way you can solve any example function in two variable. Thank you.